Hi, my name is Kevin Goldstein, and I'm going to be talking about hybrid transaction and analytics processing. A little bit about ourselves. I work for a company called Need Research. We're headquartered out of Silicon Valley, and since our inception in 2008, we've been really passionate about high-performance computing. I'd like to talk a little bit about some of the bookkeeping of what we're going to do. I'm going to introduce what HTAP is. Then I'm also going to talk about some of the traditional architectures that have emerged in the industry and what the problems with those are. Then I'm going to introduce the X platform, and then I'm going to try to marry these two together. I'm going to say why the X platform is such a good solution for building HTAP processes. Great. So first of all, what is HTAP? HTAP is an idea that tries to assess the usefulness of data over time. According to HTAP, events that are captured here at time t0 and information surrounding them are infinitely more valuable than events captured at time here tn and information surrounding them as well. And that n changes on a case-by-case basis. Examples of that is everybody's heard of low-latency trading applications, but nobody's heard of a low-latency payroll application. So it does matter about which case you're talking about, but we are also talking about lower and lower thresholds of time, where milliseconds and microseconds matter, not hours, minutes, and days. A little bit more formally, HTAP stands for Hybrid Transaction and Analytics Processing and was originally coined by Gartner. Their friends down at Forrester try to call this the same technology translytical, but whatever the nomenclature you're speaking of, both agencies are referring to the value of being data processed in the now. Stated just a little bit differently, they're trying to assess how much value have you lost by processing data later instead of processing data now. And they're also referring to this analytics feedback loop that's happening between your transaction processor and the surrounding contextual information around that, right? That feedback loop provides you with greater situational awareness and improved business agility. Examples of situational awareness are how long a customer's been shopping on your site and how long do they usually shop for that on your site, because that's how long you have left. And in improved business agilities, examples are figuring out if a topic is a trending topic before it becomes trending topic, being able to identify that key piece of information that's flowing through your system. Both companies also agree that HTAP is being driven by the use of in-memory computing. And what that means is as our hardware is getting better, so must the software techniques that we use sitting on top of that hardware. And lastly, HTAP allows us to react to business moments in a much more agile manner with greater speed and extract a much richer set of analytics than ever before possible. In fact, we can define what we're calling business moments that happen to be transient, that end up happening for weeks or even months, and we're not part of we're not necessarily part of the original system design. So a little bit about that traditional architecture, about that system design, right? This is a picture that most people are familiar with and see. This is where your traditional transaction processor, where we receive a request stream passes us an event, our transaction processor receives that event, sends it to the database, business analytics query that database, and then they produce some kind of report, your KPIs, your GUIs, your things of the sort, and everybody loves this architecture, right? This architecture is easy to sell to the CEO by the CTO. You can sell this to business people from developers. This is a great architecture because it's so elegant and so simple and so easy to describe to people. The problem is it doesn't really work. It's not a realistic architecture, and it's not realistic for two primary reasons. The first is we're missing that feedback loop between the business analytics and the processing, right? There's not contextual information being fed back. This transaction processor is only receiving a single message, and then it has to deal with that message in a vacuum. So it does the best it can. The other problem with this processor is, the other problem with this approach is the fact that everybody's putting information into a database. Right, so this transaction processor is storing its state into a database, and these business analytics are reading stuff from that database. You've now created contention, and the fact that both of these people are reading from the same place means that one of them is going to have to wait until the other one finishes. And in the world of low latency application, waiting for someone to finish on the database side is quite bad. So somebody who was looking at this and said, well, this is a problem, but we can sort of fix this. What we're going to do is we're going to break up that database between the front office and the back office, right? And we're going to have some kind of copy schema that's going to end up happening where we're, in the background, we're copying information when there's no contention. And this is a better approach, but it's also a little bit broken. Right off the bat, we've now introduced a third system in there, right? So we're not dealing with just transactions and business analytics anymore. We've got some third-party system or some third-party process that's copying front office to back office database information. So that's something else that you need to manage. And then, sure enough, a business user is going to come in and they're going to say, hey, I can't live with not real-time information. Every other case but mine is able to live with that, but I need real-time information to be able to process these things immediately, which now means you have one-offs, right? So you have an entire system that is working in one particular way aside from one or two different processes or procedures, and you need to know about those processes and procedures in order to support that system. And we're still missing this absolute required analytics feedback loop, right? That's providing you context between the transactions that you're processing and the events surrounding that processing information. Now, if this were the only thing that we had to, deal with, if this were the extent of our challenge from an architectural point of view, this might be something that we're able to live with. Unfortunately, though, what ends up happening is this, right? We take that previous picture and we multiply it ad absurdum, right? To where we're receiving, each individual transaction processor has a different request stream, and they can't be shared because they're different domains or they're coming from different clients or there's many different reasons. And this means because they're separate, they're being read into different front office databases that may or may not be shared. And sometimes they are, and sometimes they aren't. Sometimes it's a hybrid approach. And that front office database then has to copy things to its back office database. And there's a translation. Sometimes there's a direct copy, and sometimes there's a translation between different back office copies. Of course, somebody else gets the good idea that we're going to keep a master database offsite in the event of an earthquake or something of this sort, and that copy has to happen as well. Meanwhile, these business analytics are talking to the transaction processors, and they're not only talking to one, but they're talking to many. It's exhausting. It's very, very complicated, right? And so what we've done is we've introduced the concept of ETLs. And these ETL tools are responsible for this copy between the front office and the back office, and they're also responsible for translating between individual components in the database themselves. But the problem with these ETL tools, again, not only is this a complicated picture, but now you've got that extra third and very large and complicated process that you have to maintain that's responsible for copying these things between the front office and the back office database. And this leads to days of processing. If you don't believe me, think about the last time that you received a paycheck from your employer and your phone beeps at you and says, hey, the money's in your account, you're ready to use, versus when that money clears to your account, when you're actually able to use them. Now, there's something else that I'd like to talk about in this particular picture. This particular picture does something a little bit more insidious. It locks in your schema, and it stifles innovation. It makes it very, very difficult for you to add new processes because any new processes has to have a new transaction processor that filters down to your front office databases, and that has to be changed. It has to filter down to your back office. It becomes very, very difficult. You have to have a lot of inherent knowledge in order to make any kind of changes into this system. So what's the solution? And that's when you enter HTAP. So we've already talked about what HTAP is from a business perspective, but now let's talk about it a little bit from a technology perspective. From a technology perspective, it's not a piece of software, it's not a design pattern that you can find in the Gang of Four, right? It's a set of design principles, and these are surround 6 different ones. They start out with performance, right? As data is getting larger and larger, not only is it getting very big, but it's growing at an exponential rate. Our systems, anything that we design and build, have to be able to perform in the face of this data growth, right? We also have to be able to scale with this data explosion, with this increase in data, right? As a company brings something online and that product becomes more and more successful, if you suddenly end up seeing that you're handling 2 times or 3 times or 5 times the amount of data flowing through the system that you'd originally designed it for, you can't just throw in the towel and say, well, everybody's going to get put on hold while we go and redesign the system. No, your system has to be able to scale out with what's happening. And because of the previous picture that we saw, people have realized we can't be making copies of these information across multiple databases and across multiple systems. We have to be using the same piece of information for many different purposes, and that means that we have to be multifunctional. Any of the systems that we design have to serve the front office, the mid office, the back office. They have to provide business intelligence, and they have to feed books and records as well. One of the most important pieces up here is it has to be 100% reliable. As HTAP tries to assess the value of data going over time, think about the amount of value that was lost last Black Friday when Visa was unable to process data between 10 to 15 minutes on the busiest day of the year, right? That 100% reliable, absolutely critical. We're sort of past the days that somebody steps on a power cord and the entire system goes away. We're past the days of large monolithic structures where you get into a deadlock and your entire system stops performing. It has to be 100% reliable. And then lastly, we have to be able to update our products live, and we have to analyze the stream of data that's flowing through the system in order to shape the traffic and understand what's happening within our system on a real-time basis. So that's HTAP in a nutshell. As promised, I'm going to pivot, and I'm going to talk a little bit about what the X platform is. So the X platform is a memory-oriented platform for building multi-agent, transactional, Java-based enterprise applications. And that's a mouthful. I'm a little jealous of my boss and colleagues because they're able to say it with such gravitas that people just suddenly will read or hear that statement and sagely nod their heads and say, yep, that makes a lot of sense. But I'm not one of those guys, so I'm going to try to explain it with pictures. The X platform is comprised of 6 major points, and I'm going to talk about each one of them individually. The first is we're a message-driven system, and you get a boatload of good benefits by being a message-driven system, but I'm going to talk about the top 3. First of all, we provide routing. Not only are you able to send messages to different systems, but you're able to specify the kind of message that you're sending to, the kind of recipients that you want to send it to, the who you're sending, and the what you're sending, right? We provide some smart routing capabilities. And in that smart routing capabilities, we allow you to do exactly once delivery. Not at least once and not at most once, but exactly once delivery. Right? The next thing is we abstract away the difficulty in writing messaging layers. If anybody's ever worked with the messaging layers, you realize that it gets very, very complicated very, very quickly, especially if you want to start dealing with different providers of these messaging layers. And we abstract that away. We let you fire and forget. We let you say, I want to send this message to this person, and we take care of the details of what happens underneath the covers in order to get that there. We guarantee that it will get there. And lastly, we put our business logic inside our message handlers because, like I said at the beginning, we're really care about high-performance computing. So as you add a lot of layers of indirection and a lot of abstraction layers, this slows your system down. We try to provide you with the highest performance possible, and therefore you put your business logic inside your message handlers. The next thing to talk about is that we're a stateful system. Right? We keep all of our state in POJOs. That means plain old Java objects. That means that you get to keep all of your state in the language that you're writing. There's no contention between databases and file systems. One of the largest objections to keeping things in a stateful system or keeping your state in memory is the fact that people are scared that memory is volatile. What happens when if you suffer process loss or machine loss? We provide high availability. And because of that high availability, we've effectively made memory durable. That means that writing information to memory has suddenly become as safe as writing something to disk. And so, right. So the next thing to talk about is that we provide we ask you to write things in a multi-agent approach, i.e. in a microservices approach. And that means that you need to do one thing, but do it really well. Now, this is a lot easier said than done. If you think about it, if you want examples of that, think about the ls, sed, and grep from the Unix toolkit, right? Arguably the most used Unix commands in the Unix world, but man, these things never break, and that's actually quite hard to do, right? We also, the value added here comes from the fact that we do all of this while being ultra performant. Some of our financial clients running on Wall Street are dealing with hundreds of thousands of messages a second, and they're doing it in tens of microseconds. And lastly, and this ties together with being message-driven, is we provide you horizontal scalability by means of this advanced routing mechanism that we originally spoke to. This is actually such a large piece that I dedicate the next slide to it, right? The way that we provide you with this high availability is by providing a primary and a backup, and we're using pipeline replication to manage the messages between that backup. That means TCP and RDBMS, so we're not polluting the normal messaging fabric that you guys are using to communicate across all of your separate partitions, right? Not only that, we're keeping state local into each of the partition that you're dealing with, so you don't have to worry about contention across multiple partitions, which is historically one of the largest bottlenecks introduced in large systems. And we provide you transparent routing sitting on top of pretty much any of the messaging systems that are out there, like Solus, Kafka, ActiveMQ, 29 West, TIBCO RV, et cetera, et cetera. We also provide you content-based routing. This is one of the ways that we get that smart routing. So not only are you able to configure what we call channels, your destination or your highways of where you're sending those messages, but we're actually looking at individual messages to provide that last mile routing to figure out what specific instance, where we're supposed to be sending that message. So hopefully now when I say the X platform is a memory-oriented platform for building multi-agent, transactional, Java-based enterprise applications, this makes a lot more sense. The only caveat that I'd like to throw in is that we do it while being performance-centric. Usually when I'm giving this presentation, the first thing people ask is, hey, well, define what do you mean by high availability? Define how do you mean between this primary and backup? And don't you have split frame possibilities? You know, explain a little bit about that. So I like to give this, this next slide sort of talks a little bit more in detail about how we're providing that. So we're sitting on top of this asynchronous guaranteed messaging fabric, like I mentioned before. These are all the messaging fabrics that you know and love, like Kafka, ActiveMQ, 29 West, you know, what have you. What happens is we take, wrong way, sorry. We take a message off of that fabric and we figure out where it's going to be routed, right? That's part of that content-based routing, that smart routing. Once we figure out what that routing is, we pass that off to this application logic, and that's your black voodoo magic. That's your domain-specific logic. That's the stuff that you end up writing you don't know anything about. Once you finish processing that logic, you then pass that finished state into our ODS, our object data store. And that object data store tries to do a couple of things with it simultaneously. First of all, it slaps it into journal for storage, and then at the same time it passes that off into the backup slide for processing. Now, we're not passing the original message and asking the backup engine to reprocess that logic, because that will get you into the split frame situation. We're passing only the changes in state to this backup engine, and then that backup engine, once it receives that change in state, it applies it to its in-memory structures, and it passes that information back to the primary node. And once the primary node has received that acknowledgement from the backup, it then can go ahead and acknowledge the originator of the message saying that your system has been processed. We're able to do all of this very, very quickly, like I said, in the tens of microseconds, and we'll also do it in an atomic manner. One of the first questions I get is like, well, you know, my application logic is actually quite complicated, right? We've got lots and lots of different threads, and there's a huge amount of concurrency, and we ask you to stop doing that. We do this in a single-threaded, exactly once transaction manner, and this is one of the reasons that we're able to process things so quickly, because we're removing that contention. Now, again, please pay attention to this end memory storage, which this is what we're talking about here. Most applications, when they receive a request to process an application, they go to the database, they query some information, they load a few million records, they parse through those records, figure some stuff out, and then, you know, write the results out. We ask you to keep all of those records in memory. That way, every time a request comes in that needs analysis on those records, you don't have to go to a database, you don't have to go to a disk, you don't have to go anywhere else. You go directly in memory. This means that a lot of our systems are running with very large memory footprints. We start out anywhere from 8 gigs, and some of our clients are running to 128 gigs. You know, there's a very wide range about that. And then people suddenly say, well, hold on, are you keeping 2 of those? Do you have to have your memory, is your backup in memory as well, or are you just sort of tracking the changes? And the answer is absolutely. Our backup is a mirror image of what the primary application has, right? So in the event of failure, the backup will pick up processing immediately and have the exact same state. Remember, writing to state now is as durable as writing to disk. So in a failover situation, your backup will have the exact same state as the primary one does. And then people say, well, Kevin, you guys said that you wanted to keep things as simple as possible. There's some very complicated logic going on here. What happens if we have to have machine learning, or if we have to have position management, or we have to have, et cetera, et cetera, et cetera? Well, it turns out we provide you a messaging bus, right? And you can communicate with this messaging bus in very low latency times. With today's latest equipment and hardware times, we're talking in the low microseconds in order to take something on and off the wire. Now, I keep harping on this state, the state being kept in memory. And a lot of people ask me, well, is it really that important? And the answer is, yeah. It really is. You have to look at this table of when we start talking about a mechanical disk seek, it takes about 10 milliseconds, and a read from a remote data machine, a read from a remote host in the same data center takes about 500 microseconds, right? Because they have to do queries and everything else, versus accessing times right here in these main memory areas of 12 nanoseconds, 40 nanoseconds, 100 nanoseconds. That's where most of our users lie. And in fact, some of our users lie where you're doing very, very specific things to make sure that you're working with mechanical sympathy and a few other things. We're spending a lot of time doing performance analysis to make sure that we live in this L1 and L2 cache. So we really pay attention to the memory-oriented computing as far as latency goes. Now, I was actually talking about this to a non-technical person at one point, so I was describing the difference in times. I'm not even going to try to address actual values, but if you compare nanoseconds to milliseconds, it's equivalent to comparing seconds to days. So if we're talking about a 12 nanosecond read versus a 10 millisecond read, we're talking about doing the processing time of 10 days in about 1 second, right? So what we're effectively doing with our state management is we're removing the delegation of state management from a separate system and keeping it in our own process, because that delegation, when you delegate your state management, you're introducing bottlenecks, and those bottlenecks will ultimately strangle you. So I feel like I threw a lot of information at you, so I'd like to just sort of retouch on what it is the X platform provides. It gives you this transparent atomic exactly once processing. It provides application level consensus between the primary and the backup so that you have a high availability. It gives you single thread processing. It also guarantees cross-machine and cross-data center durability, gives you efficient state management mechanisms, and it's also memory-oriented, i.e. durable platform that lets you write things to memory just as safely as if you were writing them to disk. And how does it match up with the HTAP principles that we talked about originally in the first section? And it does actually quite well. Well, is it 100% reliability? Absolutely. Is it scalable? Yes. With microservices coupled with advanced routing capabilities, we can scale this to infinity as long as we pay a little bit of attention to how our messages are flowing. What about multifunctional and data duplication? Absolutely. We've shown how we can use one message to multiple different people or one message to one person, right? We have a lot of flexibility here. And performant, absolutely. With the co-located business logic and state, we keep the business logic as close to the message's hand as possible. We're able to get our clients with hundreds of thousands of messages a second in the low microseconds. Now, why else is the X system good for enabling HTAP technologies? And one of the reasons is HTAP as a whole really works with these microservices approaches. And we provide you these abilities. We provide you this infrastructure to build out microservices. Microservices are actually quite hard to build. And the reason they're hard to build is because people always say do one thing and do it well. But you don't actually get to develop your code in a vacuum. You don't get to develop, a credit or a debit from just a checking system. This has to coexist as an ecosystem. This actually has to coexist within other systems, and you have to be able to talk to them. You have to be able to see how your system is performing, how the rest of the systems are performing, what messages are flowing through the systems. I need to be able to manage deployment. I need to have a high-speed logger. I need to have all of these things. And if you have to build these from scratch, that's a lot of work in order to do one thing and do it well. And the X platform provides you with this infrastructure in order to do all that one thing well. You get to only pay attention to that one thing when you get all of this tech coming out of the box. You communicate with other microservices using messaging, but you're able to collect, display, visualize, check performance, manage deployment, et cetera, with all of the tools coming out of the box. We also provide you with stream processing and analytics. It's important to know how messages are flowing through your ecosystem. It's important to know what kinds of messages are flowing through your ecosystem, how your individual products are being affected by this message flow, and which of your individual microservices is looking like it's going to be overwhelmed, so that we can take corrective action before it does actually get overwhelmed. And this leads us directly into, we need to understand what's happening in each one of our individual microservices, right? So we need to be able to understand what part of these microservices is taking a long time. And we give you these statistics out of the box. You're able to see everything that happens from ingress to egress of a particular message. You're able to see how long your business processing model took. You're able to go so far as to see how long it took for you to deserialize from a binary format into a POJO so that you can organize your Java messages, your Java structures in a more efficient manner. Right? We give you all of these statistics out of the box, and what's more is we actually expose these frameworks for you to use, because these are the frameworks that allowed us to build a low latency platform, but you need to be able to have your own statistics built into your own microservices as well, and we expose that. So now that's it. That's pretty much the X platform. Now, what I'm going to try to do is I'm going to try to tie together these HTAP requirements and the X platform by way of an example. What we ended up doing in this particular instance, one of our clients asked us to build a POC and then later took it to prod. They liked it so much as we've ended up, and I had to change the name and the process names of everything else to, from the clients, but what they were doing is they were doing credit card transaction processing, and they were having latency problems with it. So when they came up and asked us to have a look at their systems and see if there's anything that we could do, we noticed that what was happening was their request was being processed and sent and received by this credit card master. It was then being passed to this merchant master that was reading and writing from a database and slapping all of its stuff into all of its results into tables. That's passing another message to this credit card holder, which is reading and writing from a database and storing all of its stuff in tables as well. And finally, you know, so on and so forth, until finally somebody would finally send a response with a yay or nay reply to this request. We looked at this and we said, well, this is a perfect candidate for being able to break things out into the microservices approach. And we did. We broke it out into these three sections, right? We have a credit card master, a merchant master, and a credit card holder. Now, what's important to know is that when you break things out into their own individual pieces of software, each application can be scaled by different groups and by different metrics. And that means that you're designing each application as best suited for that application instead of designing a large monolithic application, right, and doing the best that you can with each information. So for example, there was 25 instances of this credit card master, but only 5 instances of this merchant master. And the reason that I have these three different boxes scaled out is what I'm trying to show is that we have different, while these are sharded out differently, each of these applications is running in high availability mode. So we have a primary and a backup, as well as the fact that we're sharded out based off of different metrics. As well as when you realize that we have this content-based routing, as a message comes in, we're not sending it to an entire group of applications and saying, hey, figure out if this message is for you. No, because we have that content-based routing, we're sending that message to that specific application, to that specific instance within that cluster of applications that needs to be processing it. So we're reducing the amount of latency by a very large amount, so that the amount of work by a very large amount, so you don't have different applications scaling across them, right? Something else to notice about this is when the first thing started, I'd mentioned this request goes to the credit card master, to the merchant master, to the credit card holder. Well, we support end-to-end, as in many-to-many message destinations. So a single message can actually kick off work across many different applications. And this means that you get to parallelize your projects, right? You get to parallelize how fast things are working. And this means that we went from having a serial time, the sum of each of these components to the max of all of these components as our response times. We reduce processing time by something like 90% with very, very easy to do by breaking these out into microservices approach using the X platform. And something else to talk about is because we are using this dynamic, this content-based routing, because we have these advanced routing capabilities, we actually have the ability to snap in new modules, right? This means that we have the ability to do incremental release or testing. This gives you the ability to not have to design your system from scratch before sitting down to build your system, but you can instead add new components on as you think of them, right? This is that whole concept of business agility and identifying new business moments as they come up, because a business moment may not have existed a year ago, but I have identified one now and need to be able to take advantage of it very, very quickly. And I want to be able to test out those business moments, and I want to release it to 5 of my clients, or 50 of my clients, or 5% of my clients, instead of having to harden a production service and release it to all of my clients and hoping that I haven't really made a mistake in the technologies, right? One more thing about the previous slide that I always like to throw in is it's very hard for us to walk in and say, well, you need to start doing all of your historical traditional stuff should be migrated over into this microservices architecture, because there's a lot of inherent knowledge in the previous technologies. So we give you the ability to read inbound and outbound, capture and send data. We do interact quite well with traditional architectures. So just to sum up what we've talked about, we said that HTAP is all about assessing values of data over time, and it provides you with greater situational awareness and lets you react with improved agility to new business moments, right? It's driven by the use of in-memory computing and is a basic set of core principles that lets you reduce and react more quickly to any of the business moments coming up. And why the X platform is such a good solution for the HTAP approach is because we adhere to all of these core principles. We provide you that atomic exactly once processing, and we give you a novel way to capture and route and process your data as well. We also, because of our advanced routing capabilities, we do have the ability to scale to infinity, and we do all of this stuff really, really well. And that brings us to the end of my presentation. Please come talk to us, send us an email, drop us a line, anything that you want to do. Here, my email is kevin@needresearch, or you can send it to the generic email at contact@needresearch. We also have some open source demos listed on GitHub, as well as our user manual from our Talon, which is our flagship product, that X platform. I have a YouTube channel with some very useful videos for writing your own projects up, and if you want to get in touch with me via Twitter, that's okay as well.